Students, today is our next experiment for our process control 1 lab, which is to model a second order system, that means SOPDT system, into a first order system. That means we have to model a second order system into a first order system. That means in a second order system, the parameters you will get, like this is the transfer function of your second order system, in which GS is equal to 1.0 e raised to minus 2s upon 10s plus 1 into 5s plus 1. Here your k is 1, your theta is minus 2, and that means theta is 2 second, and here the time constant you have to determine for first order system, k also and theta also for first order system. That means you are converting it into a first order system. That means the process will be the same, but the transfer function denoted here is a second order system. The actual process is a second order system, which you have to model into a first order system. That means you are representing the second order. That means the FOPDT system, you are representing this SOPDT system into a first order system, right? So you will get another k, theta, and here tau 1s and tau 2s are there. For first order system, whenever you will determine the time constant, you will get a tau. So theta, k and tau you have to determine. The process will be same as the earlier experiment for a first order system, in which you have determined the values of tau, theta and k, like these variables, and compared it with the actual transfer function and determined the errors. So here you have to model the second order system into a first order system, second order system into a first order system, and determine all the variables, right? So here the transfer function is nothing but 10s plus 1 into 5s plus 1. That means 50s square plus 15s plus 1. The time delay part is this one, which is here 2 seconds, right? 2 seconds. Okay. So now the whole circuit is nothing but same as the previous one. The process will be same, but here the system is, or the process is, second order. Just you have to determine the tau, theta and k for this second order system. That means you have to convert it into a first order system. So just increase the kp value slowly to determine the sustained oscillation, as I have shown you. So here I have done, I have prepared the model for this, and the kp value, by varying the kp value slowly, I found at kp is equal to 8.254. that means at 8.254 kp value I got the sustained oscillation. So just put the here kp as 8.254, right? You have to vary slowly. You have to put the value like 2, 3, 5 by you can say trial and error method. Just slowly increase the value of kp and you will get the sustained oscillation at a particular value of kp, which is nothing but your ultimate gain, right? So just put the kp value as 8.254 and you will get the sustained oscillation like this. Just run this and you will get the output here. Here is the output. The oscillation is sustained oscillation with a constant peak to peak value or constant amplitude, right? So from here you have to find out the value of T1, T2, and likewise from T1, T2 we will get the ultimate time period, that means Tu, which is nothing but T2 minus T1. For you just take a simple one full cycle like start from here to here. If you take this full cycle, your T1 will be this point and T2 will be this point. Just determine the value of T1 and T2, right? This is your T1, that means 6.347, right? 6.347, as I have found 6.347 T1. So likewise just found your T2 also, which is nothing but 23.096 second, and find out the value of ultimate time period. That means Tu is equal to T2 minus T1, 23.096 minus 6.347, which is nothing but 16.749. This is your Tu. After that, you have got these values. After that, now you have to determine the value of K. Here at K is nothing but output area divided by input area, change in output divided by change in input. So output area, which is covered at a time period 23.096 and in between 23.096 and 6.347. So first of all, we will see 6.347. The input area initial at initial time T1, the input area is 38.86, right? And the output area at initial time, that means T1, is 1.64. Here input is input area is 38.86 and output area is 1.64. At T2, I have found likewise at T2 input area at final time T2 is 53.79 and output is 16.58. So I final minus I initial and O final minus O initial. So just take the ratio of this and you will get K as 1.00066. That means K is nothing but 1.00066, and theta and tau, formula for theta and tau is here as shown. So just calculate from this formula. Use all the things in radian, not degrees, right? If you take all the values in degrees while calculating in your calculator, the value you will get will be wrong. So theta you will get like this. Here I have done and showing you, you have to do by your own in your laptop or PC. And tau I have found like this. So after converting or after modeling the second order system into a FOPDT or first order plus dead time system, my K is 1.00066, theta is 4.511. So 1.00066 into e raised to minus 4.51147 s divided by 21.84268 s plus 1. This is the first order system. For this is nothing but the second order system converted into a first order system, right? So you can see the comparison also, the comparison of the output here. After converting SOPDT into FOPDT, you can see also the output. Just run it, take the time period, run time, sorry, take the run time. I have taken as 100 seconds. I'll run the model for 100 seconds and you will see the output or the response of the system. This is the converted first order, this is the actual second order, right? So you can easily observe the second order and first order system after converting into first order system by observing or by plotting the Nyquist and the Bode plot for these two FOPDT and SOPDT system, right? So here what you have to do is nothing but you have to just write down the code to plot the Nyquist and Bode plot for these two systems. In the command window, just write down the code s is equal to transfer function in inverted s. After that, this is nothing but the continuous time transfer function. Just you have to define this one, nothing else. System 1 is exponential, that means e raised to minus 2s. This is the actual plant of second order system. Minus 2s, 50s square plus 15s plus 1, that means 10s plus 1 into 5s plus 1. So this is the transfer function of system 1. System 2, this is nothing but after converting the system 1 into a first order system, this is the system 2. Just define it, exponential minus 4 point whatever the transfer function you have got after converting or after modeling it into a FOPDT, whatever you got, you just define this transfer function as a system 2. Just plot Bode for system 1, hold, right? Bode for system 1, then hold. After that, whenever you will write down the hold, your Bode plot will be held as it is, and into the same figure you again plot Bode for system 2. After plotting Bode for system 2, you will get the Bode plot of both the systems, and after that just plot Nyquist. Just ignore this line. I have actually done a mistake in syntax. I have wrote down Nyquist as capital N, so that's why it showed an error. So just ignore this part. Just write figure Nyquist for system 1, then hold on again Nyquist for system 2. This is the code. You have to just write down the in command window, whatever you will write the whatever command you will give into the command window, it will plot like as it is, whatever you want to plot. So after plotting, you will get these two figures. This is for Bode, magnitude and phase angle. This is for Bode for both the systems. That means this is nothing but a single system. It is converted into a first order from the second order transfer function, and this is the Nyquist for both the transfer functions. So from analyzing these two frequency response, you can see whether after converting it into a first order system or after modeling the second order into a first order system, how much accurate the system is after converting it or after modeling it. So this is the whole task of your experiment number I think 3. This is your experiment number 3, and just do by your own. The whole process I have shown, do by your own in your PC or laptop, whatever you having, using MATLAB. Try to use MATLAB 2017 or 18 minimum, not older than that. So just do that and you will get the response accordingly. You write and prepare your manual and submit it by the next week.